So when we look here, we have to find the length of MN and KN. So we have MN and KN. So we know if these are parallelograms, what do we know about opposite sides? They are congruent. So we see that the side opposite of KN is what side length? LM. If they're congruent, it means the same measure. So we know that KN has to also be 6. Okay, we want MN next. We know the side opposite of it is congruent to it. What is the length there? 15. Nice job. On this side, we're doing the same thing. We're interested in finding MN and KN. When we look at these, we see the side opposite of KN is what? 12. And the side opposite of MN is?
8.
So sides, opposite sides are congruent. If we know the opposite side, we know what the measure is as long as it's a quadrilateral as a parallelogram. Which one on the front page helps us figure out the angle measures?
So which one, the front page?
So is it 1, 2, 3, or 4?
2.
So 2 tells us that opposite angles are congruent. So if we know that W is 75, the angle opposite of that is T. It also has to be 75 degrees. Now that we've used that, we can also apply number 3. Consecutive angles are supplementary. So we know that consecutive angles have to add up to 180. So to find the measure of angle S, it's going to be 180 degrees minus 75. What is 180 minus 75? 105. So we see here we have 105 degrees. And then we can go back to number 2. Opposite angles are congruent. So that means that this is 105 degrees. Over here, we see that we have S, which is 130 degrees. 130. Angles opposite of that is angle V, 130 degrees. We want to find T and W. We know that consecutive angles add up to 180. So if we want to find the measure of angle T, it's going to be 180 minus 130. Ooh, it's going to be 50 degrees. Yep, nice job. So 130 equals 50 degrees. So here we end up with 50 degrees. Over here we end up with 50 degrees. Because angles, opposite angles are congruent. Do we have any questions on this portion?
No.
And I know they're not drawn perfectly, but when you look at these pictures, you can see that the length from N to L is 3. On the first page, properties of parallelograms, which one of those, 1, 2, 3, or 4, will talk about diagonals? Property number 4 is correct. Diagonals bisect each other. Bisect means it's going to be cut in half. So if we're looking for the length of JN, and we know that diagonal has been bisected, what does that mean the length of JN has to be?
That's going to be 3 too.
Has to be 3 as well. Yep. Over here, I heard somebody already answer this one. You see the whole length of JL is 16. If it's being bisected, so cut in half, what does the length of JN have to be? Has to be 8. So you could do 16 times 1/2 if you wanted to see it, equals 8.